Hi guys, welcome to EE62. This is Principles of Power Systems. Uh, this is your introduction into your EE. Nakalimutan ko. It's 151 before. Nakalimutan ko yung number niya ngayon. But this is basically an introduction course regarding that power systems din yon. It's power system analysis naman yon. So basically, what you'll be expecting in this course is ano ba yung broad knowledge, ano ba yung overview of a power system? Ano ba ang power system in general? Of course, your power system is there to generate electricity, to generate your power and deliver it to your end users, but yeah, it's the most obvious part, and then we have a lot of other areas within that system na hindi natin masyadong alam. Okay, so I'll be giving you an introduction into that. I'll be giving you a broad knowledge, a broader perspective on power system, and later on, I hope makakaroon kayo ng interest into this field of EE. And yeah. Basically, that's the whole course. Okay, so I guess I'll start with power system. System in itself, yeah. So power system is a system of devices, it's a system of equipment na the that whose main purpose is to generate electricity and deliver it to end users. Basically, yung ginagamit yung power sa bahay nyo, yung power na ginagamit ko ngayon to power my devices, it's being generated in a power system, and then it's being transmitted, it's being distributed para magamit ko as an end user. So that's the general idea. Okay, so that's basically a power system. Now there are a lot more areas in power system other than generation, transmission, and distribution. Of course, you have an area of power quality. Okay, well, we'll try to touch that in the latter part of the course, but it's basically what is the quality of power? Is your power clean? Yeah, that's the general idea of power quality. Is the power being delivered to you clean? Maayos ba siya? Uh, so what is clean? How do we quantify clean? We'll be discussing that later. So that's one area. Of course, you also have power system protection. It basically protects your equipment from unintended events. Yeah. So what are those events? Later on, pag-uusapan natin yon. Uh, of course, you have transmission, distribution, and then generation. I think that's the coverage of this course. We'll be talking about a little bit about maintenance. Uh, how do you, it's well yeah how do we maintain yung ating power system in a general sense, in a broader sense, and yeah, I think yun muna. uh, we have yung bentahan ng kuryente. It's called the electricity market. It's another field of research, but I'm not sure if it's covered here. Para hindi kasi siya covered, but if we have time, maybe I can discuss that later on. Okay, so I guess yun na yun. That's the general idea of what will be happening here in this course. Okay, so we'll be discussing power systems. Uh, so as I have said, the power system, its main components are to generate electricity and transmit it to end users. This is the earliest power system. Basically, before, yung standard power system is just an individual generator. It's it's connected to an appropriately matched load. So it just tells you that okay, I have 100 kilowatt demand here. So give me a generator that can generate 100 kilowatts. So that's basically yun na yan. That's power systems before. Okay, so I have this much load, I need this much power, so give me a generator that can supply that power. Okay? So, an early example of this is yung ating well, it's not ours. It's the Pearl Street Station located in Manhattan. This is basically a DC system. This was built by Edison Illuminating Company. Edison, Thomas Edison. So yun yun. So it's powered by coal. It's basically a coal power plant. Initially ang load lang niya is 400 lamps. So ganun lang kaliit. Ganun lang kaliit yung power na sinusupplyan nung generator na yan. It's a coal power plant that is supplying 400 lamps at 82 customers. So imagine 82 customers. Sobrang konti lang nun. I think mas marami pa yung hindi naman siguro. Yeah. Yung class size natin. Or maybe two sections. Yeah. So ganun lang siya. Well, 82 customers, hindi naman siya persons pala. Yeah. Okay. So it's 82 customers, maybe it's 82 households, not persons. Yeah. Okay, in 1882. So ganun na siya katanda. Okay? So it's a DC power system powering 400 lamps, and then after 2 years it grew to up to 10,000 lamps. So medyo nag-boom. Nag-boom yung power plant. Nag-boom yung power plant. The need they saw the benefit of having electricity na na-generate nung plant na yon. So yun, let's say parang maraming nag-avail. Okay? So the station was originally powered by a custom-made steam engines. So 175 horsepower lang siya at 700 RPM. Actually, mabagal pa to. 700 RPM. Today, our machines are running at faster speeds. Okay, usually 1,200 RPM, mababa pa yon, and then above and above. Ayan, it's also the first cogeneration plant. It utilizes its thermal byproduct to provide steam heating. So, uh, I, 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 I don't know, we have waste heat recovery systems ngayon. So, ang idea ng waste heat recovery systems is, you have, saan na yun? Wait lang this one, oops, yan, ay, ito. Wait lang sorry. Yan. Yan. So we have this generator, and then this generator produces a lot of heat. Okay? So in waste heat recovery systems, you recover those heat and then use it for something else. Usually, minsan, you use it for generating power also. Okay? However, syempre medyo mababa na yung heat na yon kasi it's a waste heat. So sometimes what we do in waste heat recovery systems is we add more heat. Okay? But at least nagdadagdag ka na lang, hindi ka gumagawa ng bago. Okay? So it increases efficiency because of that. And yeah, it's this is the first cogeneration kasi ginamit siya for steam heating ng local manufacturers. Yeah. So yun. So it's a cogeneration plant din. Okay? Okay. Okay. So now, this is your modern power system. So imagine that before, what we have is just tayo sa kitang. What we have before is just oh wait, ang ganda. Okay, it's because of the okay. Before we only have a generator and it just needs to match a certain load. So ganun lang, it's the power system before. It's the first ever power system. Now, we have modern grids na merong mas maraming components. I think yeah, like this one na nakikita nyo ngayon. You see, before kung generation lang siya at saka kailangan niya lang ma-meet yung load. Of course, if this is just a coal power plant powering 82 customers. So those 82 customers, malapit lang yun sa planta. Okay? So there is, I'm assuming there is really no need for longer transmissions before. Kasi DC eh, DC power pa yon. Okay? Now, and in the advent of AC power, Nikola Tesla, so yung AC power, it can it can travel longer distances, so you now have transmission. And then in the modern grid, we have with before kasi traditional grid, you just have distribution substation, distribution. You have the transmission here. This one, you have the transmission here, and then it goes to a substation para pumasok sa ating distribution. And then this distribution system, it just distributes it to the end users. I think parang parang somewhere here nandun yung ating generation papasok dun sa ano. This is basically development from your DC power nung first station. Well, it's 1882, so I guess after uh 50 years, 100 years, most probably talaga ma-develop siya ng ganito. Now, in our modern grid, this is more modern. You now have distributed generations. Basically, yung ating generations, dumami siya dahil dun sa ating renewable energy. You now have energies smaller of power plants of smaller capacities. Your wind farms, your solar farms that are uh, injecting power on your distribution system, hindi na siya sa transmission system. Well, kung ano yung difference noon, I think we'll tackle that along the course kung ano yung difference ni transmission system and distribution system. But in a broader sense, transmission system and distribution system are there to transmit and distribute power. So at some point, I guess parehas lang sila talaga ng ginagawa. You have the generator, and then for it to be delivered to your end users, so dumadaan siya sa transmission and distribution. So kung ano yung difference itong dalawang to, we'll be talking about that later. Okay? And then bukod sa ating distributed generation like wind farms, solar farms, you also have I think this is yeah. This is a remotely controlled recloser. So kung ano yung recloser, kung ano yung ginagawa niya, we'll be talking about that later. But I guess what I want to emphasize here is now you now have remote control devices. Okay? So from your traditional grid, that's the main purpose is to just generate electricity, transmit it through your transmission system, and distribute it to the end users here through your distribution system. Aside from that, aside from these three, of course, yung generation nandun yata sa taas, then distribution and users. Aside from those major components, you now have a way to control the system. So it's so this is the advent of this is I guess this is because of yung ating technology, power electronics. Nagkakaroon na tayo ng way para i-control yung ating protective devices, yung ating equipment within the system. We have switch gears. We'll be talking about that later. Of course, aside from yung ating usual generation na pumapasok sa ating transmission grid, we now have the distributed generation, which is yung ating generation na nai-inject through your distribution system. So how does it affect the system? We'll be talking about that. We'll be talking about that later. But yeah, over the last 100 years, there have been considerable technological advances because of well, it sometimes answers yung ating problem for efficiency. Of course, you want a system to be efficient. You don't want a machine, you don't want a device that is inefficient na ang dami mong finifeed sa kanya pero konti lang yung nakukuha mong output. Okay? So you don't want that system. So usually the tawag dito, the these technologies arise due to these types of these needs. Okay, you want environment friendly generating sources. Yeah, hence yung ating renewable. You have now we have a lot of solar farms and wind farms. Before, ang ating renewable sources usually uh, hydro and geothermal. Of course, yung hydro and geothermal, mainstream siya kasi they can generate electricity at higher capacities as compared to your solar and wind farms. But I guess yung ating mga bagong solar and wind farms, medyo malaki na rin. Okay? Na dumalaki na rin yung capacity na output nila. Okay? You have higher voltage equipment. So this higher voltage equipment is because of your higher voltage transmission lines. So why are they high voltages? Higher voltages. So pag-uusapan din natin yung later on. And then you have the development of power electronics. Okay, so you have electronic devices that can control these power devices. So ayan, hence yung ating mga remote control units. You have the remote control reclosers, and then we have the computerized monitoring. And actually this computerized monitoring and protection, this is basically linked to your efficiency kasi the idea is when you have an event within the power system, of course your power system is very large. Let's see, of course your power system is very large, like this one, let's say ganyan siya kalaki, and then you have an event here. So you want you want to develop a way to easily identify na, okay, nandito pala siya, dito siya nangyari. This is where my event happened. So if you have this, so it will take a lot of time to search for every point here para ma-identify mo, okay, andun siya. Okay, so you have computerized monitoring protections. There are research in easily identifying kung saan nangyari yung events. Okay? And there are ongoing researches para mas gawin pa siyang mas efficient. Okay? So the major, yeah, I think I am able to discuss these major drivers for change. Okay, so the grid of the future, ano ba yung future ng ating transmission grid? Or yeah. Or yung ating electrical grid in general. Okay, successful integration of variable energy resources presents opportunities for cleaner environment, but poses issues that include need for regulation, ramping, and reserves. Actually, this is an interesting uh ba't siya naging ganito yung kulay? Okay. Anyways, okay lang yan. So this is an interesting statement here. So the idea is that your distributed generation, it presents a lot of opportunities. Well, kasi you have very limited source of energy. Okay. Well, that's in the past. So you have renewable and non-renewable sources of energy, but yung renewable natin before, it's just geothermal and hydro. Okay, and then you have non-renewable, which is yung ating fossil fuels, natural gas, and those non-renewable resources ay nagde-deplete, nauubos sila. And sooner or later, those non-renewable resources mauubos sila. So will depend on a higher ratio of renewable resources. And medyo problema siya kung hindi natin mahahanapan ng other renewable resources kasi medyo as the time progresses, your demand increases. Okay? So there is no excuse para okay, cut natin yung supply. Paliitin lang natin siya because as the time progresses, ang the trend of the demand is to grow. It's to increase. It's not to decrease. You have higher growing demand for power. Okay? So the successful integration of variable energy resources are usually yung ating renewable resource, energy resource. It presents a lot of opportunities for cleaner environment, lalo na yung ating mga natatakpan ko, no? Lalo na yung ating mga renewable energy. Kailangan sabit sa mata ko yung ano. Okay. Lalo na yung ating mga ano nga ito sinasabi? Renewable energy. Okay. So since they are cleaner, they are from solar, they are from wind, and what's good with that is yung ating solar and wind, andyan lang siya. Okay? So gagamitin lang natin siya. We just have to find a way on how to utilize that. So the success of that, it presents a lot of opportunities. However, it it poses a lot of issues then. Why? Because they are variable. Okay, so the idea is that since they are variable, hindi mo masabi kung gaano ba talaga kalaki yung output nung resource. You just have a general idea of its output. Okay. So I think tomorrow this solar plant can provide me this because of the weather forecast tomorrow. But if something happens, okay, nagkaroon ng error yung forecast, hindi ganito yung hindi ganito yung nakuha ko, then it affects the system because kukulangin ka sa demand. Okay, so it poses a lot of issues, and that include an increased need for regulation. So because of this variability, you now have an increased need for regulation. Paano natin siya i-regulate? Ramping, ramping is biglang bumaba yung aking supply. How do you ramp up? Biglang bumaba yung aking demand. How do you ramp down? Well, ramping down is not really hard kasi you just have to switch off the supply, but ramping up is hard kasi uh, hindi basta-basta makakapagpasok ka ng power into the grid. Okay, there are a lot of anong tawag dito? Parameters that you have to consider when injecting power into the grid. And reserves. So the idea of reserve is that kung biglang magkaroon ng event, biglang magkaroon ng deficiency supply, then at least I have a reserve na pwede ko siyang gamitin. Okay? It's an ancillary service. Okay? So in the Philippines, we have La Electricista. This was way back in 1892. They came into Manila to provide electricity to residential customers. And then by 1900s, they are supporting some 3,000 customers. So sila yung nagdala ng well, hindi talaga sila nagdala ng kuryente, but sila yung nag-develop ng power system dito sa Pilipinas. And then later on, actually I find this in an article, all of this almost. Yeah, I'll show you my references later on kung nasaan sila. And then in 1902, there's a franchise bidding for construction of I like it when I'm able to write on my slides. Ginagawa ko rin to sa actual class. Anyways, in 1902, franchise bidding for construction and operation of electric power and transportation networks was opened. So nagkaroon ng bidding for electric power and transportation, hence streetcar. As you can see, yan yung streetcar before. It's a monorail. Yeah, I think so. Yeah. Okay. And then the sole bidder is Charles Swift. Nag-isa lang siya. And soon, Manila Electric Railroad and Light Company or Meralco was established. Okay, so this is basically Meralco. Dito nagsimula si Meralco. Okay. They bid for, actually hindi pa siya Meralco noon, but they bid for franchise ng construction and operation ng electric power and transportation. Actually, their main focus before is transportation, hence yung ating electric streetcar. And then, they acquired La Electricista in 1904 and they concentrated on restoring power in Manila after World War II. So, after World War II, the world is in chaos. Uh, there is a high demand na ayusin yung power system. Kasi, mahirap ang, I mean, uh, once na na-experience mo yung magkaroon ng electric power, mahirap na mawalan siya. Okay, so they concentrated on restoring electricity in Manila in after World War II. Ay, teka lang. Wait. Ay, okay. Okay, so how does it look for us now? Uh, so today, kailan? Yeah. Today, ito na yung ating coverage ng grid sa buong Pilipinas. We have the Luzon and Visayas grid interconnected by we have the Luzon and Visayas grid here interconnected by high voltage DC underwater transmission dito. Diyan yan. Yeah, I wasn't able to include it in these slides pero there's an available diagram sa power system ng buong Pilipinas. And andun din yung yung interconnection na to. I think this is in late ito. Dito. This is the interconnecting line. This is mainly, most of these are in Visayas kasi as you can see, the thing with this network in Visayas ay island siya, unlike this one in Luzon. This one in Luzon, isa siyang backbone na mahaba. Okay, isa siyang backbone na mahaba. Hindi siya tatawid ng dagat, so the construction is easier as compared to that one in Visayas. Kasi this one in Visayas, kung mapapansin nyo, kailangan niya tumawid ng dagat. So yun. So you have the interconnection line. Ito, this one, this is the Leyte Luzon. This is, saan yun? That is this one. That's that line. So the capacity of this line is 440 megawatts. So ang ibig lang niya sabihin, I can transmit 440 megawatts within this line. And then I have these interconnections on among different islands, Leyte Cebu, Cebu Negros, and then Negros Panay, Leyte Bohol. Okay? And then we don't have a connection yet in Mindanao. Hindi pa interconnected yung tatlo natin. Hindi pa siya. Okay. Let's see. Huh.